Okay, thank you for the introduction. I think this talk comes quite well after the previous one, so thanks to the previous speaker. As in other domains, and we've just been told, digital data are taking on an ever more central role in biomedicine today, transforming it into a data-intensive science. But the data that are required for biomedicine and for health research, I'm kind of putting this under one big umbrella, are increasingly being generated outside the traditional spaces of the medical system. What counts as health-related data is no longer just the type of data that are generated in clinics and labs, but it's increasingly also environmental and lifestyle data. What people eat, how much physical activity they get, how they sleep. And this data is being generated also as individuals go about their daily lives, interacting with consumer devices like mobile phones, like wearable sensors, and social media. Now, moreover, the tools needed to produce, store, and analyze this data increasingly lies beyond the remit of traditional medical scientists. So we can say that the health research ecosystem is expanding beyond its traditional limits to include new types of data, all of this environmental and lifestyle data that people are generating outside of clinics, new methods for collecting and analyzing this data, and new stakeholders, so not just clinicians and patients, but also healthy people who contribute their personal health data, and new commercial actors who help generate this data. In the past 2 years, every major consumer tech company has entered the domain of health research in a significant way. From Apple to Google to IBM, they've been a little bit older in this, to Microsoft and Amazon, even Facebook. These are companies that, for the most part, have had little interest in healthcare and health research, but that by virtue of their expertise in data collection and data analysis are becoming important facilitators, even sometimes initiators of health research. So we can call this a Googleization of biomedicine or a Googleization of health research. I'm borrowing this term from the media theorist Siva Vaidyanathan, who has a book called The Googleization of Everything, and it's quite interesting because that book was published in 2011. Every chapter, in a sense, was dedicated to a different field that was undergoing Googleization. Health wasn't mentioned. That's how new this is. And this is, I think, quite a unique socio-technical phenomenon that I've recently gotten very interested in. It's come from research that I've done on how people interact with these devices to self-track their health. So I was coming from a very user-based perspective, and this has opened up to me. It's emerging at the intersection of two relatively novel trends. So it's this idea of science or biomedicine as a data-intensive science and digital capitalism, or this intersection between digital health and digital capitalism. And what I want to do here is map out some of the challenges and ethical issues involved in this Googleization of health research, and just start pointing at ways to deal with this. So this is a kind of an initial stage in a much larger research project. Okay, but first of all, let me tell you about some of these initiatives, because I suppose that not everyone is very aware of what's going on here. 2 years ago, Apple began taking steps to make its devices indispensable for digital health. So the latest versions of the iPhone come equipped with an app called the Health Kit. This is actually an older version of the Health Kit, which has fields for more than 70 types of health data. And it basically allows users to store health data from other sources on their phone, so it acts as a kind of repository. Soon after that, the really interesting thing came along. Apple launched the Research Kit. So this is a software platform actually designed for running medical studies. It basically allows researchers to carry out medical studies on an iPhone using the phone's various sensors, collecting data via these sensors. And this is quite a hit among medical researchers. So within weeks of its launch, this is not even 2 years old, partnerships sprouted up between Apple and some of the world's leading research institutes, Yale, Stanford University, the Dana-Farber Cancer Institute, Mount Sinai Hospital, and this is growing. So currently there are more than 20 studies using this research kit platform, with over 100,000 participants involved in these studies to date. There are studies on asthma, cardiovascular disease, diabetes, autism. For the most part, these are taking place in the United States. 2 studies are just being launched in the Netherlands. These are kind of European pilots for this. Apple has also started partnering with pharmaceutical companies, with GlaxoSmithKline just recently, and there's talk of plans it has to develop cardiac devices. Like Apple, Google is also exploring ways for tying personal health data to researchers. So the baseline study, this is in collaboration with Duke and Stanford universities. For example, this is a study where they're seeking to enroll 10,000 healthy volunteers, track a range of genetic and molecular data, and link this with personal health records. So this is supposed to form kind of a baseline data, a kind of picture of ideal human health, and the idea is to track these people as they transition into ill health, and of course develop preventive treatments based on that. And this is only one of the many ways Google is pushing into the life sciences. Among others, it has a project to cure death. It's developing blood glucose monitoring contact lenses. It's also working on making its cloud computing platform a necessary passage point for genomics research. So Google Genomics, this is a service that aims to offer a kind of centralized database into which researchers can move their genome data and run queries on it. So they're also offering analysis services here. It's called the Big Query, I think. Google's not the only one in this genome cloud business. It's competing with Amazon, Microsoft, and IBM, and there's a real price war going on right now. So I think the going price now is about $25 per genome per year to store in Google Genomics. Now we've got 23andMe. This is a Google-backed direct-to-consumer genetic testing company. It's a bit older than these other initiatives. They started in 2007. And 23andMe started out selling personal genome kits to people privately, so online, but with a clear intent on developing research capacities based on the genetic and phenotypic information of its customers. So the idea is that you can buy one of these kits, you do this, you spit into a little kit, send it off, it gets analyzed, and then the company also asks you if you'd like to give back this information to the company along with phenotypic data generated by filling out questionnaires that they can use in research. This is called the 23andWe research arm. So this has resulted to date in about 40 scientific publications. And there are now dozens of these types of direct-to-consumer genetic testing companies, but 23andMe is the biggest. And it now, from what I understand, has the largest repository of human genomic data in the world, other than forensic DNA. So, as some of these high-profile collaborations we're seeing here attest to, these initiatives are being met with some enthusiasm. And this is because they address important limitations in traditional approaches to research that have become evident in light of the possibilities offered by mobile technologies and so-called big data analytics. So doing research on an iPhone, for example, allows researchers to access various types of data. Things like how active people are, how they're sleeping, what they're eating, how they walk. Gait is one of the things that's important in the Parkinson's study. So this type of linking of very heterogeneous data, it's at the core of visions of personalized medicine or precision medicine, however we call it, and big data science in general. The idea is that linking these various data sets is what will lead to new, interesting insights. This type of research, kind of the research kit platform at least, it also enables researchers to recruit many, many more participants than was possible in the context of traditional clinical studies. So we're talking about millions of iPhone users who can join these studies quite easily. It's only a case of giving informed consent virtually. So Apple likes to boast that within the first 24 hours of the Stanford cardiovascular study, they had recruited 11,000 participants in the first 24 hours. So this has just been published, some data from this study in JAMA. And so there has been a drop-off of participants, but they still have 40,000, data on 40,000 participants to publish. Now, similarly, in the field of genomic research, there's been in the past years, of course you know this, a real explosion of quantities of data. And hospitals and universities usually do not have the computer capacities to store all of this data, nor the analytic powers to analyze it. So companies like Google and Amazon, well, they do, yeah? Genomes contain a lot of data, but this is not very big compared to what they're used to dealing with, kind of searches on Google or consumer purchases that Amazon is used to working with. So I don't know if you can see this is taken from the Google Genomics site. They're saying to deal with genomic information at scale, the life science community needs new technologies to store, process, explore, and share. 2 years ago, with this in mind, we formed Google Genomics to help the life science community organize the world's genomic information and make it accessible. This is Google's mission statement all along, yeah, organizing the world's information and making it accessible. So these companies basically are saying that they have the means to revolutionize medical research in an era of personalized medicine and big data, yeah? In the terms we're used to hearing from Silicon Valley, medical research seems ripe for disruption. But this Googleization of biomedicine or of health research, it's also challenging existing ethical norms and frameworks in novel ways. So I've been working on mapping these issues out, and I think we can organize them into 3 clusters or 3 types of challenges or questions. The first is kind of at the core questions about what kind of science, what quality of science will result from these types of projects. These are questions that are, in a sense, internal to science. And then further, we have questions about things like privacy and informed consent. What are the risks to individuals participating in this type of research? Will these companies start trading these profiles? What does it mean to give informed consent virtually, as is done in the Apple Research Kit? So these are questions that are typical of the field of research ethics and bioethics. And lastly, we have a different set of questions that I think remain, even if these first 2 clusters are appropriately dealt with. And these are questions of power and control. So what new power imbalances are emerging in this expansion of the health research ecosystem? Do we want companies that are already so powerful in other domains to also become key players in medical research and healthcare? How will this affect future research agendas? How will it affect the public interest, the common good? So these are all interrelated, but different types of questions. And I would argue that from the research I've done over about the past year, that in the current scientific and technical literature and a little bit of policy literature that is looking into this, it's these first 2 clusters, especially issues of privacy and informed consent, that are the main emphasis. And what's happening is that they're eclipsing this last category. And I would say that this is detrimental to the conversation, because without situating this phenomenon within the political economy of data sharing and use, we're not going to grasp exactly what's going on. So that's my underlying claim. But let's take a little bit of a closer look at this, cluster by cluster. So in the first one, these questions of scientific rigor, there are concerns here about the quality of the data generated by wearable devices and apps. So the fact that these are often self-reported, this data, or that different devices can give very different readings. So if you're wearing an activity tracker on your wrist or in your pocket or on your hip, it's giving different readings. It also depends what kind of wrist you have. So fat wrists, hairy wrists, tattooed wrists all give different readings. So this is an ongoing discussion, I would say, within the medical community. There's also no way of verifying that this data belongs to the person who says it is. So it's very easy to join a research kit study, but phones can be shared, stolen, etc. People can lie too. Now, another concern raised here is the potential for population bias. So research carried out on an iPhone, for example, will be research carried out on a specific population. And that's a population that happens to be younger, wealthier, whiter, and more and better educated than the general population in the world, but even the general population of smartphone users. So it's about 20% of smartphone users have iPhones, and they're also younger, healthier, and more affluent than the Android users. Sorry? Yeah. I mean, this is the kind of population, right?
It's Google. No, Google feels lucky. I'm just
well, this research kit has actually been now opened up a research gate to Android phones, but there's issues with there that are technical ones. I don't know exactly what's happening there, but there is an effort to do this. Now, researchers using the research kit and at 23andMe, 23andMe is the same issue. It's the same population as the iPhone users who are doing this kind of direct-to-consumer genetic testing. So the researchers, they're quite aware of this, of course, and usually their response is that no sample can ever be entirely representative. So this population bias is inherent to all kinds of studies, not just those using these technologies. Furthermore, what's suggested is that the limited inferential power of these studies is offset by the massive size of the samples. Yeah, so this is an assumption that's quite characteristic of the hype around big data, right? That the sheer volume of data sets will make up for any imprecisions, that it will neutralize biases. But this assumption, it's quite problematic, yeah? Bias times 1 million is still bias. And while traditional studies somehow are very aware of inherent population biases, this awareness may get drowned out in the hype around big data and the size of data. So there are discriminatory effects here that take place when size gets wrongfully associated with objectivity, that are exacerbated by what some theorists call big data's exclusions. So all those people who are not routinely engaging in data generation practices basically won't be part of these research populations. So what we see here is that this is not just an epistemological issue, but a question of social justice. Yeah, research based on these data sources may skew towards specific population and conditions that affect those populations. Moving on to the second cluster. Privacy, of course, is one of the main concerns here. A lot of this research is predicated on the idea that the more these data sets can be linked, the greater the insights to be drawn. But linkage makes anonymization increasingly difficult. And this tension is intensified in the context of research facilitated by commercial actors in various ways. So there are concerns of corporate tracking. So many of these apps occupy a quite ambiguous space between medical and consumer devices, and it's not clear what privacy policies apply and if users read or understand them. There's quite a lot of research about how we all do it, right? Check the consent box and just to be able to use the app without understanding what's written in there.
Even lawyers don't understand.
Yes, well, they're writing them, but I guess some of them understand it. We also know that many of the popular apps do share and sell data. So some of the top players in the physical activity device markets like Nike are selling this data with, for example, advertisers, possibly insurers. Now, Apple has been proactive about this. And some of the first research kit apps were developed in collaboration with Sage Bionetworks. Sage Bionetworks is a non-profit company that acts as a kind of data repository and manager. So they basically get the data from the phone, de-identify it to the extent that this is possible, and they're very honest, I would say, about how this is not really possible, this de-identification or complete de-identification of data. And they allow what they call qualified researchers to access this data to do research. And they store the data there. So Sage is a really interesting actor in this. They're this positioning themselves as this kind of ethical mediator in this research landscape. They've also developed an e-consent mechanism that Apple has taken on board. But there's no requirement that a research kit app developer use Sage. So Apple has kind of outsourced responsibility for ethical compliance to the researchers who will use ResearchKit. Now, no legal informed consent issues have emerged with the ResearchKit so far. This is not the case with Google. So I don't know if you're familiar with Google DeepMind. DeepMind is an artificial intelligence offshoot of Google. It's a company that Google bought some time ago. And it was recently quite a lot in the news because it beat the world champion Go player, which I don't understand this, but apparently is much more difficult than chess. So this is a step up, right, in artificial intelligence. Now, at the same time, Google DeepMind was the focus of a smaller controversy concerning the terms of a data sharing partnership it entered with 3 NHS hospitals in the UK. So this agreement, this took place about 6 months ago, grants DeepMind access to fully identifiable information on 1.6 million patients who have gone in and out of these 3 NHS hospitals over the past 5 years. It claims to use this information to develop an app that will allow doctors to identify and monitor acute kidney disease. But many of these patients didn't come into the hospital for kidney disease. Now, there was complete silence from politicians and regulators on this. I don't know if anyone here has heard about it. It took investigative journalism to discover this some months after it had happened. New Scientist broke the story. And this partnership, by the way, was just extended for another 5 years a few weeks ago. Now, this controversy, when it did finally emerge, was mostly about the question of informed consent. So it was framed in a research ethics framing. Had DeepMind actually obtained consent from these 1.6 million patients to access this data? The short answer is no, it didn't. The longer answer, and the one that DeepMind and the NHS are still holding to, is that, they didn't need consent because this is being used for direct patient care. So we have a notion of implied consent. Implied consent means that if in a relationship with your practitioner you share information, your practitioner can share that information with others, another specialist, for example, if that's in order to care for you directly. So you don't have to give informed consent there for that information to be shared. So DeepMind and the NHS are saying that that's what applies here. This is a form of implied consent because it's for direct patient care. Again, it's not clear that all of these 1.6 million patients would ever benefit from this kidney disease monitoring app. Now, challenges to traditional understandings of informed consent is something we're seeing more and more in this, in any type of research that uses large digital data sets, where it isn't possible to predict all future uses of the data and the risks. So this isn't particular actually to Google or other companies stepping into this field. But seeing this solely through the perspective of research ethics and informed consent limits this to the question of informed consent and privacy. When deeper than this, kind of the elephant in the room, runs the issue of who stands to benefit from this and how. Yeah? The question of public benefit, and if it's enhanced when such large amounts of personal health data are appropriated by an already powerful commercial entity. Okay, you might say, all right, but industry-academia partnerships, this is nothing new, certainly not in the biomedical context. Big pharma immediately comes to mind. This is just another instance of commercialization. I would argue that this is a different phenomenon. To begin with, pharma companies, they do often act as gatekeepers of data generated in the studies they run, but they usually don't have the wealth of longitudinal data about people that a company like Google has access to, nor to the type of kind of across-the-board predictive analytics that this data can feed into. Furthermore, the business models of these companies are not as straightforward as big pharma's. So it's often unclear how and when profits will be made. Yeah? So what's in this for Apple? Is it just the sale of more iPhones? DeepMind, for example, currently isn't charging the NHS for the work it's doing. Mustafa Suleyman, the co-founder of DeepMind, has explicitly spoken about not nailing down, I'm quoting him, the business model too early so that they can figure out how to monetize these services later on, that is, when they become indispensable. The business model that is at work here is closer to what Evgeny Morozov has called data extractivism. So this is the idea that data is needed in order to build and train algorithms, to develop machine learning models, which can then be translated to produce sophisticated services that can be sold back to providers in the healthcare sector as elsewhere. So this seems to be what this kind of flexible business model is about. So we have an apparent clash here, between two different moral repertoires, what the sociologists Boltanski and Thévenot would call the market and the civic orders of worth. And this is particularly because what's happening here is not just that private profit is being made. This is something we know in academia-industry partnerships. But that this is being made based on an appeal to people's sense of altruism, of goodwill. So a lot of empirical research shows that people are willing to share personal health data if it's in order to contribute to research. People often want to participate in research. And these companies are capitalizing on this by mobilizing the rhetoric of participation, of doing good, of solidarity in very strong ways. Everyone here, from consumers to CEOs, are being configured as data philanthropists, what this IBM executive has coined. I love this term, data philanthropists. They're all data philanthropists here. Of course, this is true across the digital economy. It's not only in this healthcare or health research context. But I think this is particularly disturbing as it's particularly efficient in the context of health research, which is typically associated with the common good, with public value. And this underlying tension between these civic and market orders of worth, this kind of moves us beyond questions of, I would say, just privacy or just informed consent. Yeah, this leads us to a different set of issues about power and control. Much of the enthusiasm surrounding this type of research stems from the idea that this data may help constitute a new global medical resource. I'm quoting Eric Topol here, that scientists will be able to easily tap into. So this is predicated on the idea that data sets will be open, and there's a lot of push from funding agencies in this direction, of making data open and accessible to all. Thank you. It was a bit threatening. But as these companies start compiling their own data sets, they will also become to various configurations mediators, gatekeepers, or proprietors of this very valuable health data, what's needed for the future of big biomedical research. So there's no guarantee that these data sets will remain open, or to what extent they will be open. It's been reported that the Google baseline study that I mentioned in the beginning will have a lockout period, for example, when only paying customers will be allowed to access the data. 23andMe, the direct-to-consumer genetic testing company, has recently entered collaborations with pharmaceutical giants like Pfizer and Genentech for amounts of up to $50 million. So we're starting to get an idea of how valuable access to these data sets is. And this contrasts, quite starkly with visions of open science and notions of a cloud commons for genetic research. And this is particularly problematic, I would say, when public money is channeled towards the expansion of these data sets. So this has been the case with 23andMe that recently received a 1.4 million grant from the NIH to expand its data set. It's also the case with the Google and Amazon-backed genomic clouds. So the National Cancer Institute has paid millions of dollars to help set these up. It's basically looking to move the Cancer Genome Atlas from the NIH onto these servers. So this may lead to what some critical data theorists are calling new digital divides. So we have this divide between people who generate the data and these companies, but also between these companies and traditional research institutions. Digital divides based on access to the data sets, so whereby companies may restrict access to paying customers or to their own inside researchers. So in the past year, Google and Apple have been quite aggressively recruiting top life scientists. They're really building departments for health research. This began with Thomas Insel, who was the head of the National Institute of Mental Health, has moved to Google. This happened last year. Access isn't the only issue at stake in these emerging digital divides. The new forms of technological and computational expertise that these companies bring to the table may also contribute to a redrawing of power relations. So, excuse me, as I mentioned, the kind of rallying cry of these companies is that they own the means to rejuvenate medical research in an era of big data, that they have the cutting edge technology, from iPhones to clouds, and even the data analytics capacities, this data mining that's required, say, for genome analysis. And so these companies transpire, in a sense, as the natural partners with whom traditional research institutes should collaborate, not just on specific projects, but in what is being conceived as really a new mode of data-driven, technology-enabled science. And there are real questions, I think, of who the experts are here, if these companies will be facilitating or displacing research, public research institutions. So the terminology used here, I think, is telling. I don't know if you can all see this. This is taken from the website of Duke University. It's not a Google website, when they proclaimed the launch of the baseline study. And it reads, Duke and Stanford are to assist Google X. It's not the other way around. Philosophers and sociologists of science have always argued that who asks questions in science determines which questions get asked. So the issue here is, to what extent will these companies start asking research questions and shaping the research agendas of the future? So just as an example of this, and there are quite a few, but Anne Wojcicki, who's the CEO of 23andMe, used to be married to Sergey Brin of Google, and they very openly have spoken about the fact that they want to promote Parkinson's research because Brin has a rare form of genetically transmitted Parkinson's disease. So we're lucky there. Parkinson's happens to be quite a common disease, but you can see where this could go. All right, I can conclude. Try to do this quickly. Okay, so for me, this mapping of these issues at stake here, this is really just a first step in a much larger research project. All right, it's quite diagnostic. It's a diagnosis. A lot more conceptual and empirical work needs to be done to see what's happening here exactly, what value conflicts are at stake. I think other moral repertoires are also being used here, not just the civic and market, but there are additional ones. So that's some of the empirical work I'd like to do. But this is needed, I would say, in order to help shape new models of governance of personal health data use, because that's what we really need here, a rethinking of ethical governance of personal health data use. I'm trying to cut short here. Now, one type of response to this, this phenomenon, this Googleization of health research, one way of dealing with this is to think about increased individual control of citizens and patients, ownership over the data. So this is one direction that many people are thinking in. I don't think it's the best way to go either. So data ownership, as many legal theorists will explain, is somewhat of an illusion. We have this illusion that maybe we own. Time is running out. Okay, so I don't think that's the way to go. More fine-grained consent means more individual control, but it fragments collectives. We need greater collective, public control of data collection and use. This could entail that private corporations using data to improve products pay public bodies for use of those data sets rather than getting them for free. We could introduce a tax to ensure that profits made on the basis of personal data is somehow flows back into the public domain. So there are some researchers working on this, Barbara Pranczak, for example. Another thing to do is think about these commons-based regimes. I think this is a really interesting way of thinking about this, of thinking of personal health data not as a private good, but as a common good that's governed collectively. So we have these repositories. I don't have time to explain what they're doing, but they try to allow people to upload their data onto these repositories, manage it there, and again, they allow access to researchers. And this can be based on specific criteria, but it can be a collective decision-making profit. So I think this is one thing at looking into in the future. And I mentioned taxation on use. Harm mitigation funds also would need to be put in place there. All right, so this is a bit speculating about which way to go. Thank you.